What is going on, everybody? My name is Michael Levan. Thank you so much for joining me today. And we are going to be discussing the pros and cons of overall just deployments. Now, really what we're going to be focused on is performance issues. And when I'm talking about performance issues, I'm talking about overall, what are the top 5 biggest things that you need to think about and look out for when you're deploying to Kubernetes. And you may kind of look around and see other pieces of content and blogs and articles, etc., that go into the actual performance. But what we're going to be talking about is from a real world production level perspective. If you walk into an environment or if you're creating an environment for the first time, what do you kind of have to look out for? Because that's going to be the biggest thing. And there are, in my opinion, 5 key things that you must think about before deploying anything at all. Now, the first is going to be cluster scaling. And I would say this is a more or less obvious one as you deploy Kubernetes, as you kind of see the way that it works. You're going to see this one talked about a lot. So essentially, let's say you're running in the cloud. So you're running Azure Kubernetes Service or Google Kubernetes Engine or, something along those lines, EKS in AWS. You only have to worry about the worker nodes. The control planes are managed for you. The worker nodes really come down to how those pods are scheduled. Now, here's the thing. Let's say, for example, you're having some performance issues. So, you turn on the Kubernetes cluster autoscaler and, it scales up from 3 worker nodes to 4 or whatever the case may be. Well, that's good, and it works, don't get me wrong, but when you're doing that, it does take some time. So that cluster autoscaler, when it kicks into action and the new worker node is spun up or worker nodes are spun down, that does take some time. It's not a, quick thing. So you may have performance issues as that process is occurring. Now, to get around that, there are a few different things. In AWS, for example, well, not in AWS, but an AWS specific service is Carpenter, and Carpenter are just-in-time nodes, how they like to describe it, which it actually makes sense because from a performance perspective, it is faster using Carpenter than the cluster autoscaler in AWS. Now, with that being said, Carpenter is only for AWS, so it'll be utilized if you're only using EKS. From an Azure perspective, for example, you can use virtual machine scale sets, which allow you to essentially have VMs in like hot cold mode for your worker nodes. So you'll have a pool of VMs and, they'll get put online if, the load is more on your Kubernetes cluster, and then those VMs will get taken down if that load comes down. So, if it's a super busy day for you, maybe you're using all of those worker nodes. If it's a quiet day for your business, maybe you're using half of them. Who knows? All depends on how your application stack works, or more importantly, how the performance is occurring. And then you also have some different things as well. So like with the virtual kubelet, you can utilize, Azure ACI bursting. So what that'll do is that will actually have the virtual kubelet look at ACI as if it's another worker node and push pods out and containers over there. You can do something similar with AWS Fargate, which is like your serverless Kubernetes. So you don't have any worker nodes or anything like that. It's just scaling up, scaling down as needed based on the workloads. Now, one thing that Sosivio will help you out with is to have the ability to see how your cluster is performing. So let's go ahead and go to the UI really quick. All right, so I'm in the UI and I can see this cluster overview. So as you can see, I'm at 96%. Well, I was just at 96%. Now it looks like I'm at 100%. So it's all going to be based on how my nodes are running. So under my nodes here, I can see the memory and the request. So this means, and I have a demo application running right now. This is why this looks so terrible in terms of it being at 100% because I don't have limits or requests or anything set up. But as we can see from a node perspective, I'm running out of memory and CPU. So I can see at this point, okay, my cluster may not be working or running as expected. So now I need to maybe add another worker node, or I need to figure out what's going on in my pods. So if I click on one of these nodes, for example, I can get the specs here, and then I can say, okay, my pods need to take X amount of CPU, X amount of memory, and then at this point, I'll have to scale that up or scale it down. So the point is that Sosivio isn't going to make you guess. You're never going to have to guess, oh, do I have to scale up? Do I have to scale down? You can have reports. You can see, okay, this is how my cluster has performed from a worker node perspective, from a memory and CPU perspective over X amount of time. This is how it's performing right now. Oh yeah, let me turn on auto scaling, or let me add in VMSS or Carpenter or something along those lines, depending on where you're running Kubernetes. Okay, now the next thing is going to be your pod scheduling. So pod scheduling is going to go hand in hand with cluster scaling. So when you're thinking about pod horizontal auto scaling, you're thinking about, okay, I have 2 replicas. My performance is up because it's a busy day, so the load is up, and because of that I need to scale from 2 replicas to 4 replicas, for example. Well, unless your cluster has the proper resources for that, as in memory and CPU is available on the worker nodes, you're not going to be able to scale out, which means your pods will attempt to be scheduled, but because there are no resources available, they'll just kind of sit in this pending mode. So I'll give you an example here. Let's say you're trying to save costs, and you're trying to save costs by saying, okay, at night, my Kubernetes cluster isn't getting hit all that much, so I'm gonna, crank it down to 1 worker node every night. But then in the morning, customers start to hit your application, and because of that, maybe cluster auto scaling kind of kicks into play, and it's like, oh, I need to scale up, but it's taking a significant amount of time to scale up because you only have 1 worker node running. So yeah, it may be good from a cost savings perspective at that time on paper, but you're losing a ton of performance, and that means customers might go in another direction in terms of what product they're using. So you want to ensure that your pods have the ability to be scheduled when needed, and the way to do that is with understanding proper resource utilization. So again, let's head over to Sosivio really quick, and I want to kind of showcase that from a pod perspective. Okay, so again, I'm in the dashboard here, and what I'm going to do is I'm going to go to my pods. And as we can see here, our pods are taking a significant amount of memory. Our pods are taking some CPU, not all that bad, just appears to be a lot of memory being utilized. So I'm going to click on my insight and metrics. And then as you can see here, my sock shop namespace, as the demo app that I'm running, is taking a significant amount. It's actually taking more than Kube system itself. So I'm going to go to sock shop, and now I have the ability to see, okay, what my memory limit is, what the request is, what the CPU limit is, what the CPU request is, and I can see how it's kind of performing here, and I can see how the pods that are running here are performing. So right now, actually, we're doing okay. However, I may want to ensure that I have, VMSS up and running. That way I have an extra worker node or 2 sitting on the back end just in case, because the cluster that I'm running, the instance size isn't all that big, right? But I can kind of come in here and I can see how my pods are performing, what load they're under, real-time metrics that are available to kind of see, again, what load they're under, and then ultimately make a decision on, okay, this cluster size is perfect for these pods that need to be scheduled and I'm not going to have any performance issues, or yeah, it's taking up a significant amount of resources. Let me go ahead and scale this cluster up. All right, now the next thing here is picking the right cluster for the job. Now, I think I'm going to start to slowly get into things that I feel like people aren't talking about all that much. When we're talking about the right cluster for the right job, we are talking about, for example, let's say you have 1 cluster, and that cluster is running everything, your entire application stack, and it's also running the Istio control plane and the Argo CD control plane and the HashiCorp Vault control plane. You probably want to split up those workloads, because to be honest with you, Kubernetes isn't this black box cluster where you just throw everything in and hope for the best. You still want to segregate and isolate workloads depending on where they are. So in that case, let's say again, you have an Istio control plane, you have a HashiCorp Vault control plane, and you have an Argo CD control plane. I would actually take those and put it in its own cluster. I would call it a management cluster. So you want to ensure that you're choosing the right cluster for the right job, because let's say you got to restart that cluster at some point, or let's say you got to move workloads at some point, or let's say the scheduling isn't working as expected and it's taking a little bit longer for the cluster autoscaler to get the proper worker nodes up and running for your resources. That could put your entire, literally all of your tools, including your internal application stack, in a not so great state from a performance perspective. Now, the next piece here is networking, and the top 4 things that I see from a networking perspective are: pods don't have IP addresses, which then they cannot be scheduled. Workloads can't be properly secured because there's not a CNI in place that can, for example, utilize network policies. So EKS out of the box, for example, just using the standard AWS CNI, it does not support network policies, which means your security cannot be done properly. which can, of course, lead to major performance issues. Now, the next is the network is way too small, so that VPC is incredibly small, and therefore, depending on your workloads that kind of come up, you cannot schedule them properly, and therefore you have to redesign your entire network, which is not an easy thing to do. And then the last thing is you want that security-centric CNI like Cilium, for example, but perhaps it's not available in the managed Kubernetes service that you're utilizing. So you have to make sure that you understand that right off the bat first. Now, from a best practices perspective, AWS, Azure, GCP, they're going to have best practices for the network that you should be setting up for your managed Kubernetes services. So you want to make sure that you take a look at those, because to be honest with you, it's going to differ. Kubernetes is Kubernetes, but it's always slightly different depending on where you're running it. Now, the final thing is, and again, I feel like this is something that's not talked about all that much, but it should be, is going the enterprise route or the homegrown route. So when I'm talking about enterprise, I mean enterprise tooling. So tooling that you're paying for, and then the homegrown route is open source tooling. Now, one is not better than the other. However, depending on your team size, depending on the expertise of the team, depending on what the team can manage, it does matter. So I'll give you an example. Let's say your organization wants to save a ton of money, so they decide to go the homegrown route. Well, if you go the homegrown route for, let's say, monitoring and observability, you're going to have 4 to 6 different tools. But then if you go like Datadog or another tool, for example, you have one tool, you're not managing it at all. All of those monitoring and observability pieces are inside of Datadog, and your team doesn't have to manage anything. But again, from the open source perspective, your team has to manage all of it from start to finish. The deployments, the maintenance, everything. Does your team have the expertise? Is the training available? Do you have enough team members to manage all of this? These are all things that you have to take into consideration, because that can definitely be major performance issues. If your team cannot manage the workload of all of these different tools are not going to be running as expected. So with that, those are the top 5 things that you should be thinking about from a real world performance perspective when it comes to Kubernetes. Thank you so much for watching.